Two-Tone Miles here for episode 2 of Ska and Biology, and for episode 2 I can think of no better intro music than Two-Tone Army by the Toasters. I'm going to go see the Toasters on February 2nd, so Two-Tone. Alright, pretty excited about that. So today's episode, what is life? Following up on previous episode, what is biology? Biology being the study of life. It's going to be important to have a definition for what life is. And so for today's episode, got a couple props here. One prop being myself, the other being my kitty. This is Potato. Say hi, Potato. Got a houseplant. And got a biology study book here. So yeah, got 4 examples there. Now, from a very early age, you could probably say Miles, Two-Tone Miles, the cat, the plant, they're all living. The book is not living. But why? So what is life? We have to first define life before we can really study biology. We have to have an agreed upon definition of what life is. And it's funny, I was talking to my wife just the other night, and she was saying, well, that's a very philosophical question. Well, not so much for biologists. We have a definition for life, or at least a working definition that includes 7 phenomena, 7 things that living things do that help define them as being alive. So what are these 7 things? The first one is homeostasis. Now, homeostasis is kind of a big word. It means the ability to regulate an internal environment, and that's also kind of a long definition. So let's give some examples. 98.6 is core body temperature for humans. That's a pretty simple example right there. What happens when you get too cold? Well, you start to shiver. Versus what happens when you get too hot? You start to sweat. So there's that ability to regulate human core body temperature at a constant 98.6 degrees. Another example would be salt balance. Too much salt in your diet, your body is going to naturally adapt and excrete it in the urine. Versus the phenomenon of salt hunger. I remember one summer I was drinking about a half gallon of water every day over the span of about a 6-hour span. And after weeks and weeks of doing this, I noticed that, man, I was really hungry for potato chips. I was drinking so much fluid that it was essentially diluting my salt balance. And so my brain was triggering this salt hunger as a way to consume salt and regulate my internal environment. So homeostasis is number 1. Number 2, organization. Biology is typically organized with the smallest unit being the cell. The cell is made up of organelles, which we'll get into a bit later. It has the genome. It has all the building blocks for life. Now, in some cases, life can be as simple as a single cell, but sometimes you get greater order built on top of this. Cells being organized into tissues, tissues being organized into organs, and organs being organized into entire complex organisms. Organization on top of organization on top of organization. So organization is number 2. Number 3 is metabolism. I like to think of this as the ability to basically convert chemicals into various forms of chemical energy. So you've got 2 forms basically of metabolism. You've got catabolism, which is the breaking down. You eat, you extract chemical energy, you're breaking down the food in your digestive system. And then you've got anabolism, the shipping around of those various components of the meal to, say, the muscles to build stronger muscles. And energy factors into both processes. You're getting energy out of catabolic pathways, and you're using energy in anabolic pathways. Taking energy to you're getting energy out of breaking things down, and you're using that energy to build other things. On the subject of building other things, growth is going to be number 4. So pretty simple what growth is. You know, we humans, we grow taller as we age to a point. We can definitely grow larger in girth if we don't watch our diet. A plant could grow higher towards the sun or expand its root mass. A fungus would expand its network of hyphae and grow larger. So growth is one of the factors of life. Adaptation is number 5. That's a little bit of a tricky one for me because you can have adaptation during the life of the organism, such as learning behaviors to help make you more adapted to survive, and then you have adaptation over several generations, over, say, evolutionary time, in which the species itself adapts to a changing environment to become a different species from the original. You've got, as number 6, a responding to stimuli. So, you know, for instance, plants would grow towards the light. Responding to stimuli, it can be very different. Like, if I'm cold, my response could be I could go down and turn up my thermostat. My kitty's response would probably be sleep by the heating vent, take a nice 17-hour nap. Ain't that right, kitty? The plant may go dormant in response to the cold, or in the case of frost-sensitive plants would die entirely, unfortunately. Number 7 is reproduction. So this constitutes both sexual reproduction, the combining of male and female gametes to produce offspring. It also covers asexual reproduction, such as budding. In the case of this mother of thousand plant, you can see little plantlets here being born on the leaves that will fall off and create new plants. So that's another type of, say, asexual reproduction. It's a vegetative structure producing whole new plants. Where this gets interesting is we have these 7 factors, and we have instances where our concept of life is challenged by organisms which, say, fail to do all these 7 factors, such as a virus. A virus cannot reproduce on its own. It needs a host species. It needs the host cellular functions, basically, to reproduce. And so a virus itself cannot reproduce. Similarly, you know, while the host of a virus may be able to regulate temperature, a virus itself cannot do this. So there you have an instance where you have something which meets some of the components of what a living thing is, but not all of them. And that kind of leads to the debate of, are viruses truly living or not? It's kind of an interesting debate. I'm not really sure what the great minds of the generation have decided on this, and I'm not even really sure where I come out in that matter. What's interesting about these 7 factors is that differences in these factors help us to distinguish the types of life. For instance, my friend the plant here has chlorophyll as one of its metabolic products. I don't have chlorophyll, and Kitty doesn't have chlorophyll, so that helps us to distinguish plants from, say, animals. The ability of 2 individuals to mate and form a stable hybrid is critical to the definition of a species. If the 2 can mate and produce stable offspring, they are considered to be of the same species. If not, you're looking at different species. So these 7 factors really help to define life, and then define within life the various orders of living things. And again, what really is interesting about these 7 factors is what happens when you aren't able to do all these 7 factors. I mean, it's death. So if your core body temperature drops too much or goes too high, you can die from that. An example of homeostasis out of whack. If various organs of the body are not functioning properly, if the natural organization is out of whack, that can be fatal as well. Deficiencies in metabolism can create chemical imbalances, which can be fatal. In the case of growth, the plant stretching towards the sky, if it fails to have a growth rate that allows it to continue to grow and compete for light against other plants in the area, it may die because it's not growing as fast as other plants. It's choked out by the more aggressive species. Adaptation, failure to adapt, can cause deaths of entire species. A rather scary prospect that we as humans may be able to adapt the environment at a rate that's faster than many of these species are able to keep up. So species going extinct because they cannot adapt quick enough to the changing environment. Failure to respond to stimuli. You're given the stimuli, I am hungry, I am cold. Failing to act on those can create lethal situations. Reproduction, failure to reproduce as a species. When the species death rate is higher than the birth rate, when there are so few mating individuals out there that mating just becomes such an increasingly rare occurrence, that can lead to entire species going extinct. So, again, pretty interesting stuff. So, let's go back, recap. What is life? Well, we define life by 7 phenomena. We say living things are able to do all of these things, or in the case of virus, most of these things. And we say something that does these 7 phenomena can be classified as living. So again, what are these 7 phenomena? Homeostasis, ability to regulate internal environment, that's homeostasis. Organization, the building of a complex organism out of simple building blocks that are organized at every step of the way. Metabolism, the ability to convert food into chemical energy, into growth mass. Growth itself is one of the factors of life. Adaptation, the ability to change over time as a response to the environment. Response to stimuli, the ability to react quickly to an environmental stimulus, to say go towards the light or go towards a source of food. And reproduction, the ability to reproduce new life from existing life. So these are the factors that define life. So thank you for watching, and enjoy the outro.
Just because you're nobody, it doesn't mean that you're no good. Just because